course, today's topic is in securing inland water supply. And this is a new opportunity area that we're opening up for venture creation at Deep Science Ventures. So I'll provide a quick overview and then I'll pass off to my colleague, Pino. So in today's call, we're going to first focus a bit on DSV's approach to identifying venture opportunities. Second, we'll be focusing on the areas of focus, particularly in DSV's climate theme, which is what's driving this current venture opportunity. Then we'll have a quick breakdown of the water space sector, of how we broke down this space, a bit of a focus in on inland urban water scarcity and some prospective solutions and approaches. And finally, the venture opportunities. At the end, we'll be open for questions and input. So please, during the talk, don't hesitate to put some questions and comments into the chat and we'll make sure to answer them. And we're especially looking for your expert opinions to challenge our thinking. All right, I'm going to pass out to Pina.
Right. Hi, everybody, and welcome to our webinar. I'm head of scoping in the climate team at DSV. I do have a food technology background, and I have worked on a whole range of different technologies in the past, all relating to cutting edge technologies with an environmental or social benefit. So it was really a whole range of different technologies, ranging from genetic modification of rice to increase the iron content, over 3D printing of food and also lab culturing of meat. During my PhD, however, I did work on capacitive deionization, which is, of course, a known water treatment technology. And I was looking at to what extent we can use that technology in order to purify proteins. But for the webinar today, I will walk you through the slides that are covering, that are giving you an overview about Deep Science Ventures in general, how we work, what our scoping methodology is, and then later on, Eric will take you on a deeper dive around the water opportunity area more specifically. And I hope, of course, on the back of this webinar, we are also getting you excited as the experts in the field to come and join us, to work with us to develop a new set of impact-driven companies solving challenges around water or securing water supply. Now, Deep Science Ventures in itself is a venture creator, and all the companies that we are building, ultimately, we are building them in order to build a future where both humans and the planet can thrive. And we have 4 different sectors that are approaching this ambition from different angles. So one is focusing on curative therapeutics, focusing on the developing of new personalized therapeutics, for example, for cancer, but also other diseases. Then we have one sector focusing on scaling intelligence, computation, and automation. And then we have a third sector that is focusing on agriculture and restorative cultivation. And then, of course, there's the 4th indicator, which is, the 4th sector, which is us. And we are focusing on problems and challenges around climate change and the ambition to reverse global heating. DSV, or within DSV, over the past 5 years, since the early starts of DSV, we have been building 35 companies, and all today contributing to a portfolio value of more than 260 million pounds. And I think one indicator which is very indicative for the quality of the companies that we are building is that 86% of the companies that we have created are still remaining active. And this is really an indicator that shows our approach to venture creation is or yields high quality companies that are really needed in the market and are really solving important problems. Just to give you a bit of an overview about some of the companies that we have in our portfolio, there's, for example, Mission Zero, which is a direct air capture company, and they have just last year managed to secure funding from Breakthrough Energy Ventures, which is, of course, also a very good achievement in this area. Then there's also Supercritical, for instance. They developed a new technology in order to produce pressurized hydrogen in order to decarbonize industrial heating, for instance. And then there's also Thermulum, where they're focusing on the development of high-performance nanomaterials for building installations. And just to mention one more company that is not listed on the slide, because we're just in the process of spinning it out. They're called Aquature, and this is one of the first companies that we're spinning out, which is focusing on wastewater treatment, and not only wastewater treatment, but the combination of wastewater treatment and chemical production. So that one is coming out soon. So stay tuned for that one. Then just to give you an overview about the fundamentals of why we are building the ventures the way we're building them. Because in the end, our ambition within the climate team at DSV is to build successful companies that are able to have an impact quickly. Because in the end, the climate crisis is pressing, and therefore the demand is high for new technologies that help us to change our behavior and change the processes and the workflows that we have been developing over the last century. So there's really a need for new technologies and new companies that help solving these challenges. Yet the way technology commercialization is done at the moment is slowing this down. And there's 4 main reasons that we have identified. First of all, the siloing and the lack of knowledge transfer between different research areas and between different individuals within leading institutions. Then a very important one is also the temptation for tech push, because there's of course always the intention, if you have worked for 10 years on a specific technology in order to understand it, that in the end you do want to commercialize it independent of whether there is market fit or not. So it's of course quite a temptation to do that and to basically be carried away with your own biases if you have been working for a very long time on a specific technology. Then there's also significant constraints around bureaucratic systems and again, the temptation to think around silver bullets and to lock down talent and funding around specific technologies that are considered silver bullets without looking at the full range of technological options that we're having in order to solve a specific problem. So our approach, or when we are building companies within DSV, we try to flip these constraints and to learn from them and to propose an alternative to them. And here the main focus is actually to propose or to build ventures starting with a solution pool. So when we are starting a venture creation process, we don't start with a specific technology that we're excited about and then try to find a market fit, but we try to turn this process around. So we first try to understand the actual problem and the actual challenges that we are facing within the market or within a certain environmental problem, and then we are assessing the existing technologies against the problem, and we try to identify the best technology that helps us to solve the problems that we're really facing. So it's really the solution pool and like a first principles approach that we are promoting within DSV in our venture creation process. And then on top of that, we are also, of course, promoting collaboration between us and the founders, obviously, but then also between the founders that are currently within our cohort and between the companies that we are building. So to really create an ecosystem of companies that in the end all have the ambition to work towards climate positive impact. Now, just to give you an overview about our scoping process or our process that we use in order to build new companies, we're calling this process DSV Alpha. And here, the first 4 boxes are basically the steps that we have already been taken on our way to find an interesting company that helps to solve water scarcity. So we have basically defined a sector level outcome, and we have a partner in place that is equally excited, the partner is equally excited and interested to solve the problem that we identified. we have specified an opportunity area that we think is specifically interesting and relevant and has a lot of opportunity for venture creation. And now we are in the process of finding a founder. So the first 4 steps are what we are covering with the core team within DSV, and especially step 3 and 4 were the steps that Eric was the main driver for. And now with you, if you're interested to work with us, we will be tackling step 5 to 8. So it would be about deconstructing the opportunity and reassessing the opportunities and specific technologies that we have identified that might be relevant and ripe for commercialization. And then iteratively building a team, and then basically spinning out the companies and growing the company step by step. Now, just for me, my last slide here is giving you an overview about the different opportunity areas that we are currently working on within the climate team. So there we have in total 3 opportunity areas that are focusing on drawing down historic CO2 emissions. So here we are commercializing negative emission technologies with different strategies, including direct air capture, but also geochemical and biological means to draw down CO2. Then we have 3 opportunity areas that are specifically focusing on avoiding CO2 emissions from current transport systems, industrial heating, and specifically also steel production. Then we have a new opportunity area where we are focusing on avoiding methane emissions specifically, and then another one focusing on securing the supply of critical minerals, specifically to unbottle any supply constraints or that are relevant for the energy transition. And then the last one, which is of course the key focus for today's webinar, which is avoiding inland water scarcity. And I guess with this focus, I'm handing back to Eric, who can give you very great detail about the opportunity area in itself.
Well, thank you so much, Fina. That was a really wonderful overview. Yeah, so I guess a brief introduction. I'm the face that you've probably seen in the current blast and the webinar. I guess not on the emails that you probably saw Noah, who's helping support us in the back. A brief about it myself. I have a PhD from ETH, and most of my background focuses in a wide variety of hard sciences, starting from kind of biological and then touching on chemistry, physics, and material science, and my work on artificial photosynthesis. So I certainly do have some interface, and especially materials interacting with water. And that's where a lot of my focus has been. But of course, in the past months, a lot of my research has been in trying to break down the water space to understand what are the main underlying constraints that we need to tackle, and ultimately build some sort of projects that can solve some of the biggest bottlenecks in addressing water scarcity. So without further ado, let's jump into breaking down our water area. So a bit of a broad context on water scarcity. So an estimated about 4 billion people will live in water scarce areas by 2050. It's a very large area, very large amount of people. And this is just the people. This isn't even the economic impact. There's oftentimes a frequent trade-off between agricultural and urban water usage. This isn't in all areas, but in many areas, there's a large amount of even conflict that emerges between these trade-offs. Population growth and climate change are the key driving factors here. I think population growth, especially asymmetric population growth, addresses some 80 to 90% of the water scarcity that we're going to be facing by 2050. Climate change is approximately 10 to 20% rest. And up to 6 billion people are currently facing some form of water scarcity already. At some point during the year, a good example, for instance, is this past couple of years in Europe, where water levels reach historical lows, but for the most other years, they don't reach certain levels of scarcity. So the asymmetry and the sporadicness of water scarcity is increasing, as we all know from climate change. And lastly, these effects cause huge humanitarian, ecological, and economical issues, and all of which are reasons why this is an area is important and something that we want to address. So just a really quick breakdown by sector. We decided to take a look at kind of the broad main ways to take a look at water, and the three main sectors that we can potentially consider as industry, agriculture, and domestic water uses. To take a look at number-wise, in today's water consumption, industry has about 850 kilometers cubed. Agriculture is by far the largest, and domestic is the smallest. But that's changing by 2050. Domestic will more than double. Agriculture will remain about the same, and industry will also expand tremendously. Overall, this is something around a 55% demand increase. And in a world where water is becoming more and more sporadic and asymmetric in its supply, creates an urgent problem that we need to address. So how do we solve? The way that we try to solve these things at DSV first starts, though, with what do we solve? And this brings us to our top outcome. Ultimately, our main goal would be to secure all water supply while reducing negative impacts on environment and climate. And because we have an agricultural team currently working in a similar space on addressing water needs in agriculture, the primary focus in this particular area was broken down into two main areas, domestic and industrial. With domestic, the goal in this case becomes to sustainably supply water needs for the about 4 billion people facing severe water scarcity by 2050. And the industrial focus would be sustainably supplying water for at-risk water scarce industries. Now let's break down a little bit further. If we take this high-level outcome, a 55% global water demand increase by 2050, again, ignoring agriculture, but again, agricultural water use isn't going to change much. We can break this down a bit further into 5 main areas. And the ultimate goal of breaking down these areas is to make sure that we come up with a complete amount of a complete way to address all possible solutions under this top-level umbrella. And what we've identified here is 1, we can try to eliminate use or reduce water input requirements. 2, we can increase the volume of the water source or input. 3, we can potentially redistribute or build access to water. 4, increase treatment of water supply. Or 5, eliminate loss during or after use. Now, you probably noticed that not all of these components are the same size. Some of these are larger than others, but ultimately this full range allows us to completely tackle the top-level problem. And this is what we call high-level tactics. Now, as indicated, as we scope out this tree, and the tree gets more and more detailed, and we identify constraints to the top-level issues and try to identify solutions to them, we get farther and farther down the tree. And as we get farther and farther down the tree, ultimately, all of these possible solutions that we can come up with should be able to derive from these top 5 tactics that we've identified. In essence, the opportunity area that we ended up focusing on is currently not possible to solve for expected water scarcity in inland urban centers. And we identify this because, as its statement, we've found evidence that currently there's about 2 billion people that will be face an unsolved issue by 2050. Inland urban water scarcity is an issue that isn't solved by local water supply, and also isn't something that can necessarily be addressed by other technologies such as seawater desalination. And of course, if we break this down a bit further, we can potentially even break this down into areas which can increase local water inputs and areas which cannot increase local water inputs, which I'll get into a bit more detail a bit later on. So now let's talk about some prospective approaches. As you probably saw in the article shared a bit earlier, we wanted to take a look into a couple directions. One direction where we focus on where there is enough water, for instance, precipitation, we can potentially increase water collection or treatment. Now, 2 other areas where there's not enough local water, we would increase new water conversion. And that would be, for instance, water treatment, desalination, extraction from air, etc. In total, these bring the 3 modes of action that we think are most important to address: water collection or treatment and new water conversion. A brief side comment, though, about water collection and treatment, where there is enough local water. globally, fascinatingly, there's about 100,000 kilometers worth of water that falls on the Earth in the form of precipitation. In contrast to that, human society uses about 4,000 to 5,000. So in essence, we know there is more than enough water that exists. The challenge is, how do we get it to where it needs to be used? So breaking it down into a few highlighted approaches. One, we can adapt our existing systems for collection. And this would solve for asymmetric shifts in water supply. One prospective example of that could be reservoir enhancement. And we'll slowly break this down into, say, more creative and novel methods to solve for our problems. Other potential methods could be remote sensing, directed evolution of our current systems. In this case, by being able to detect how our systems adapt and how our systems are affected by water scarcity and water supply, we might be able to also slowly address water demand and address water scarcity in that way. Of course, there are three main ways to focus on this. It's satellite, municipal water system monitoring, and in situ environmental water monitoring, all of which have a number of interesting avenues that are currently being explored in current startups. Third, we could also consider a little bit more novel areas, such as moving towards fast groundwater regeneration. Groundwater itself, about 30% of it is, about 30% of groundwater is stressed, and also represents a tremendous energy usage in many places in the world. I think in India, for instance, about 30% of all their energy, all their electricity usage. Now this fluctuates on time of year. About 30% of all their electricity usage goes directly to groundwater extraction. So in many of these cases, there's a really there's a big tie-in between energy usage and water extraction. But there's a lot of novel areas that we could potentially address fast groundwater regeneration. And the key here is how, again, we can solve for an asymmetric shift in water supply, as we've seen in California, and in many other places of the world. You'll oftentimes have both droughts and floods in the same place, just at different points in the year. And this sporadicness and this asymmetry of water supply is only amplifying. California, Chennai in India, the list goes on. But some potential ways that we can consider here that we've identified are, for instance, some rapid transfer membranes, at which there's been a tremendous amount of development recently. And in addition to that, we could consider also injection wells, providing new technologies that can allow some impermeable membranes or filter membranes in the soil that can also make sure that we don't end up polluting the groundwater supply as we inject new groundwater. There are also potentially new ways to address runoff. So some 90% of runoff is wasted in urban settings, primarily due to the impermeable concretes and impermeable buildings and materials that we use in our municipalities, which also only further the issues with the local water scarcity that municipalities ended up causing. And there's been a little bit of movement in this space. Of course, there's still a number of challenges that need to be addressed, such as the strength of these permeable materials, especially if they're used for construction. But there's a lot of really potentially new ways in which we can adapt water extraction from the environments that we already have. And if we even move a bit further, we could even consider even modifying the soil. This is actually some areas that we're already potentially considering in different areas in DSV. And there's some potential movement in already some, say, non-toxic photoactive soils. There's some people working already on glass activation for water treatment. This is actually a pretty well-vetted technology, but potentially these technologies can even be adapted directly into soils, which happen to have some of the largest areas. Challenge would be, how can we adapt such solutions to make sure that we limit environmental issues? Now, a bit of a breakdown of this area. As you can see, there's a number on the right-hand side of the screen. We have a number of current players, and by mapping out the current players that exist in the field, we can also identify potential gaps that are currently not being addressed. In all of these areas, I would say that there's a large upside, meaning there's a big impact we can have by increasing the local supply. But the challenge in a lot of these things also becomes, how can we establish something that currently isn't being addressed? And as you notice here, addressing runoff is something that has very few people working on. Now, this list isn't exhaustive. That's the point of the founder in residence. The founder in residence would come and work with us to form a really complete overview of every possible way that we can solve this issue, identify the current companies working in these areas, and then perfectly identify the niche that we want to target, ideally the biggest possible problem that we can solve with one or two technologies. Now I'll move on also to the creation of new water. So in the areas where it's impossible to supply local areas with enough water, the only other possible solution, other than distribution of water, which we've also taken a look at, is the creation of new water. Now, in areas where brine has infiltrated groundwater, we can consider, for instance, some light and low energy inland desalination. Membranes come in handy here again, and or potentially other new desalination technologies, which there's quite a number of that. Happy to elaborate on that a little bit later. There's also a lot of new technologies, such as that have been making a lot of headlines recently, such as extraction from air. This isn't a new technology in areas such as Peru and a wide range of native societies around the world, where they've harvested water from humid airs using fabrics. But there's a lot of new polymer materials, ways that we can essentially adapt both old and new technologies to allow us to get the water that we need to have. And finally, of course, there's even some exotic technologies that we're probably also familiar with, such as that actually widely facilitated already, such as artificial cloud seeding. Now, obviously, there's a number of constraints in this space. Currently, a lot of people are using silver iodide. It's expensive and also costly. Of course, that still hasn't hampered people from trialing out this technology. But the question would be, in all of these approaches, how can we build something that's not only scalable, but something that is environmentally friendly and something that is able to solve for the cost and water requirements that we need to make the biggest impact. And lastly, there are some additional possibilities, such as extraction from rocks or chemical conversions. Just put this here as an example of some of the creativity that we expect to have from the founder in residence. Not all solutions are obvious, but it's important to cover everything. In fact, actually, extraction from rocks is something that's rather fascinating. In the driest desert in the world, in the Atacama, we have barely any life forms, but some of the few plants and few organisms that exist end up extracting water from rocks, where you could end up extracting the hydrates that exist, and then when they decompose, they form water. So there's a wide amount of area that we could potentially consider in this area, a wide amount of possible approaches that we can consider by being a bit more creative. Just to briefly overview the companies in this space. So again, we have a few areas working in the desalination space. This is in new desalinations that exist, and including extraction from air. So we have, I think, about 10 or so companies working in the space that we've identified so far. And of course, artificial cloud seeding is an established process. Several companies and also countries are working on these technologies. Now, just a little bit about this opportunity. I'll briefly touch upon founder recruitment. So in this particular, specifically, we are looking for a profile of one, a highly creative mind and demonstrated rapid learning curve. We want to see someone that has learned difficult things in a short amount of time. We also want to look for someone that has a strong knowledge in the water sector, and someone that is urgently motivated and has a background showing that this is something that they want to make an impact in. In addition to that, we also want to show that they have an industry and startup experience, they thrive in certain environments, and target the large outcome. For instance, they want to make the world a better place, and they've demonstrated that this is something that they do work on. The last thing is that we need to find someone, again, that's extremely driven to solve for water scarcity, the outcome that we care about in this opportunity. If this sounds like you, we'll have the job description a little bit later on in the conversation. So what does the process look like? Well, in the first to 3 months, we try to deconstruct the opportunity area and identify a short list of approaches. Now, what does this mean? As indicated before, we start off with the top level outcome, right? How do we establish the 55% increase of water that we need to have globally? And how do we establish a little bit lower? How do we solve for inland urban water supply? When we expand out this horizon, we try to make sure that every possible solution is identified, or every single possible way to solve is identified. From that complete list, we then identify that short list, and that's what we refer to here. And then in the 3 to 6 months, we take that short list and we try to find the best approach that we can move forward with. In the 6 to 9 months, we take that best approach, and we also move to co-founder hire. And then later on, in the 9 months to 1 year, we develop investment readiness with pre-launch and a focus on the tech and commercial aspects of the idea. And finally, in the first year to the year and a half, the company is incorporated. And then moving on from that, we'll raise seed, we'll connect with Series A and other investors, and that's essentially what our network also helps support with. We have a good experience with building out businesses, and something that I'm sure that Noah also in the background will be happy to contribute to if you have questions later. So if this does sound like you, I would of course encourage you to please apply. The QR code is on the screen. The job description will be linked to, so if you sign up that way, you can see the job description. Applications are currently being assessed on a rolling basis. And the process looks a bit like this. You'll have a first interview, which will be focused on identifying your determination. Why do you want to solve for water? What is your background in that area? Then we'll try to get more into the technicality, the technical issues. So we'll focus on a case study where we identify your problem solving. We see how well you are in those areas and how well you can creatively identify other solutions. Interview 2 will be expanding upon that technical aspect, because that's something that's really core. Ultimately, this founder in residence program is to really make sure we identify the best way to solve for the biggest problem. So we really need to drive home the technical and the creativity here. And then finally 3, because we're forming a business, we need to really test and understand both the magnetism and commercial expertise that you have. Now, our offer, one thing that's really exciting about DSV is that not only do we have a really great team of experts with a track record of building out great companies, but we also pay you to start your own company. We care about the outcome, and we want to make sure that the best person is solving for it. We pay a monthly stipend of £2,916, and this gives the guaranteed income before securing a pre-seed investment. And finally, or second, we also have deep involvement throughout the process, providing support in the following areas: exploring approaches for venture-backed company, building your team, and finally accelerating your company. And over the course of 12 to 8 months, we'll be evaluating the existing approaches in the field with you. Now, founders and residents will also have access to our proprietary software, including our internal knowledge graph and the hiring platform Scale. Support will also be provided with our experienced team at DSV, which 95% have either a PhD or a C-suite experience, and often both. This is a picture of our team. Now, Adam is the director of our team. Great guy, really experienced across a wide variety, especially really impactful climate space. Noah, who's also on the call with us, has a great background in business development, over 10 years as a founder and CEO of a venture-backed startup. Pina, who you saw earlier, the head of scoping, a wonderful manager, works across multiple deep tech startups, and very knowledgeable. Finally, we have myself, Rahul, and Lucas on the second row. All of us are associates who kind of come together and bring some of the ideas that we want to focus on and get the ball rolling on building out our quote-unquote outcome graph. Now, finally, at the very bottom of the slide, you'll see our founding directors, the two on the bottom left, Mark and Dom, both extremely smart and dedicated people in this space. I really respect them both. And then on the bottom right, we have Edward in the agriculture team. It's important to highlight him because, of course, the water sector acts across many different spaces, and they're working on places on problems such as agriculture transplantation, which has a lot of overlap with water. All of which this team and beyond, including a tremendous amount of advisors and other founders, as what Pino mentioned, will incorporate the supporting atmosphere that you have at DSV. We also have access, again, to a lot of external professors and experts in the field. Now, to close things off, our planet needs water solutions, and perhaps our planet needs your solutions. If that sounds like you, please apply as a founder in residence for solving inland urban water scarcity. And again, the QR code is on this slide. Please don't hesitate to ask any questions. And I'm out. Let's see. So I think that the first question, should we move on to questions? Noah, do you have anything else to add?
No, I think, no, that was great. Thanks, Eric, for giving such a great overview of the space and the venture creation process. Pina, likewise, thank you. Yeah, I think we're good to move on to Q&A.
All right, so the first person asked, how would solutions like adapting plants to decrease water use be in the scope of DSV? No, that's a really, really great question. This is also something that, again, the agriculture team is really looking into. One of the areas that we actually, that I looked a little bit over, and I think I have a node in our graph just for reference, if you want to see here. I don't know, you can see my screen. We have a large amount of thought that goes behind this process. So here's a quick snapshot of how we break things down. Quickly on that, there's actually a number of areas where we're taking a look into existing plants that actually grow in salt water, some of which are even fruiting bodies. And there's also even some approaches to actually consider genetically modifying some plants in order to see whether you don't necessarily need to use as much salt water, as much fresh water. Certainly a really big issue, as said before, there's a big trade-off between agricultural water usage and urban water usage. And so, yes, regardless what you want to solve, if you want to end up solving for inland urban water scarcity, some of that ends up becoming agriculture. One of the biggest areas of water scarcity, especially by 2050, is likely going to be in the Upper Ganges region, Upper Ganges plain in the subcontinent, so from India to Pakistan. And that area also happens to be some of the largest agricultural regions. So yes, of course, if you end up adapting plants, or if you could find some way to also resolve the melting glacier problems, which is a really significant issue around there. These are solutions that you need to be able to identify in order to solve for these key areas. All right. Pina and Noah, don't hesitate to jump in if there's something you want to add in these things. JC asked, how is water quality being considered? And having enough quantity is just half the battle. And yes, that's a very good point. Now, here, I think I put an appendix slide a little bit on this. So let's see if I could find it. Here we go. Yes, so I think certainly water quality is really important. But so this is a quick snapshot of my graph. Sorry, I should have made this a bit more pretty. It's a bit difficult to see. But in the list here is essentially every single way that I saw people currently tackling water treatment. Water treatment and water quality is extremely important. But one of the things that I realized is that it might not be as important right now than just simply making sure there is enough water. When you have areas such as inland urban areas that literally do not have enough local water, water treatment isn't going to be the first challenge. And there's a lot of people working on that. While some of the ways that people are solving for water treatment isn't necessarily being adapted everywhere. And I agree, a lot of cost issues need to be addressed in water treatment, particularly potentially around solving the constraint around aeration, which is one of the main bottlenecks for solving water treatment. It doesn't look as if that there's as much space here, and a lot of people are actually solving for a lot of the main constraints in water treatment. So that's why that's why I particularly focused on the water supply end of things. But happy if you have more to expand upon that, JC, please feel free to write something else in. But really great question. Are there any other? Happy to do this. We have the whole hour, so please ask away. I think well, one of the really interesting areas, by the way, when it comes to there's of course a tremendous amount of overlap between water treatment and water supply, even in the technologies themselves, and there's also a really fine line at what point is called water treatment, what case it is increasing supply. A good example of that is in desalination technologies. where in essence you have to treat the water, of course, in order to remove the salt to create fresher water. And a number of technologies exist that can really address these multiple areas. And this is what we also try to identify at DSV is what are the key impactful areas that can really make an impact across multiple areas. One of those areas, for instance, is in membranes. And obviously there's been a lot of really, really great work there. If you can have, for instance, solve the constraints around biofouling, and just fouling in general, along with the rapid transfer, which membranes normally provide, then you might be able to solve something, even if the cost is potentially high in a membrane. It's a small amount of material, and if you can get a high enough flow through, maybe the cost justifies it. And all right, so there's another question, a couple more questions in the chat. I guess I'll start from the top. How can venture backability of these solutions be assessed if water is essentially free? Oh, yeah, exactly. That's a really, really good question. And I think certainly one of the big concerns, I think identified also somewhere on our outcome graph, the issues about culture and our relationship with water. I think first I'll say to the anonymous attendee, if this is something that you have a good solution for, please tag us up. I'd love to hear more thoughts on this area. There are some potential ways in which we can address water usage. And I'm not postulating this as a solution, but something that we have identified is helping to address things such as, for instance, the virtual water trade, which allows us to, you would have to, most of the time, most likely you'd have to establish some sort of credit or some sort of way in which you evaluate the price of water for the environmental impact that it has. In some situations where the water supply is so high, it could potentially mean that water is cheap to the point that essentially is treated as free. But in areas where you end up negatively impacting society and negatively impact environmentally, the local environment, then the water in those areas, for instance, might end up reflecting the cost. So I think that there are ways to at least address if the free water is having an impact. If it's not having an impact, then there's no need to address it. And then also, when it comes to venture backability to solutions, it's particularly focused. I would say that most of the time, then we would be really focusing on those areas where it's a problem. And in those cases, the water most of the time isn't free or shouldn't be free, especially in areas such as again, in the subcontinent, about a third of India's energy, electricity is being used for water extraction, and it's becoming a cost issue for farmers that are already underneath a lot of financial strain. So it's certainly not free in a lot of these areas. And by being able to address some of the price difference certainly can allow venture backability. But those are also challenges that we end up trying to answer later down the road. What we spin out needs to make sense from a financial standpoint, so we can make sure that you scale the business, so you can end up scaling the technology and scaling the impact. Otherwise, it's very, very difficult to make it real. Hopefully I didn't blab too much on that answer, but really great question. I really like that. All right, and JC, yeah, thanks so much. A lot of really great questions here. Please talk away. JC asked, in many cases, DACA, for instance, have prioritized quantity and paid attention to quality only after it's become a problem. Personally, I think the two shouldn't be considered separately. Looking for a paper to send. Yeah, thanks for the paper. Yeah, I see. Water, yeah, why safe water requires challenging quantity. Yes, exactly. So just for reference for those on the recording or those that can't see the paper, the main point that this paper is targeting is why safe water requires challenging the quantity versus quality dichotomy. I still completely agree with this. And I agree that, especially with the person that is interested in the founder residence. And thank you again so much. Like, this is exactly the challenge that I want to have in this call. It's the goal of the founder residence to really find out, where they think the biggest impact is. I still think that, for instance, there's about 5 megacities that exist, especially in the subcontinent, but by 2050 have populations and industry and agriculture that's literally impossible to supply enough water. You can't supply it by the water trade. You can't supply it with groundwater. You can't supply it with a local water supply, especially throughout the entire year. That while I understand that you can't have water treatment separate, I guess the point of view that I came from with is, which do you do first? You can't treat water when you don't have any water. And ultimately, I was trying to imagine that, especially in some of these situations, yes, we do have some water treatment issues that need to be addressed, obviously need to be addressed and make cheaper, but we really need to make sure that in these key areas that don't have a solution, right? Some of them have a potential solution, but they cost more. I just think cost is an issue, but the areas where you literally do not have a solution, but there are possible solutions, this is the key area that I think has a tremendous amount of upside, because there's nowhere to go but up. If you end up supplying at the very least the water in the first place. But a really great question, and keep on challenging. I love it. All right. Eco Ahmed Solutions says, in connection with the JC question, water quality is very important, looking at the fact that our knowledge on groundwater and its quality is very limited. Again, existing technologies for treatment are very costly. Again, pollution of fresh water is scaling or increasing, I guess, is what I mean, and probably might need more attention in this project. Yes. I think I'll briefly go back to my tab here. The first thing I want to address again is at least from my analysis, which really happy to hear from experts in the area. It seems as if people are working on almost whenever I try to look into an area to address water treatment, including cost, it looks as if someone has a solution. Maybe there's not a tremendous amount of solutions, and I agree this is still an area that has a lot of upside, and certainly more solutions need to be addressed. But it's an area that, as I certainly see from this chat, there's a lot of pain and there's a lot of interest, but there's so much interest that actually, even though I guess a traditional argument has been, okay, yeah, we should increase the water. When I actually take a look at people in that space, there's really not that many people in the space. And so that's why I still really focus on the supply issue rather than necessarily water treatment. But that aside, briefly back onto groundwater and treatment, wanted to tag over here. I think that is really, really good points. Here we go. Groundwater enhancement is an area that really doesn't have too much work. The only area that I could, sorry about that. The only area that I could really find is on groundwater remote sensing, where there's a couple of companies. I just checked it right before the call, and one of these companies is out of business. So it's a difficult area. Really, there's only one person that I could find working this area, but it does look that, especially when it comes to groundwater sensing for the purpose of groundwater replenishment, is an area that might actually be pretty interesting. And that's something that I think should be addressed in one of the areas that I personally think could potentially help solve some of the upper level constraints that we've identified. One of the, of course, there's also people working on satellite groundwater sensing. UN agency is also doing this, so that's not an area that's necessarily interesting for local groundwater remote sensing. But really happy to hear if there's more thoughts on that. But from my point of view, groundwater is one of the largest, has one of the potential largest upsides because it allows for a wide range impact. There's already, currently it's already being treated as, okay, I don't need to probably tell most people on the call this, but it's already being treated as somewhat as a one-way valve. We take things out, but things don't come back in order to have a sustainable ecosystem, in order to address the energy problem, in order to address the cost problem, in order to address the supply problem, and potentially even address the challenges around reservoirs, reservoir fouling, reservoir clogging, and methane emissions and evaporation, all these other things. Perhaps I push a bit too much, but all of that really makes me feel as if groundwater is something that really should have a lot of focus on. All right, so the next person asked how would you address water scarcity problems in areas with also energy scarcity? Man, I love these questions. Since you mentioned India and rural areas usually don't have energy security, well, I think you also kind of answered it. The answer is, well, use something that uses less energy. and that's kind of how we try to turn things around at DSV is, well, the existing approaches seem as if energy is a big problem, right? Can we solve this problem by creating less energy? In fact, actually, some of the solutions, like what Pina mentioned earlier, one of our in-house companies that fingers crossed will be able to spin out later on is Aquater. They treat wastewater, but at the same time, they create value-added chemicals. So they're actually creating money out of treating wastewater. Essentially, wastewater is something that ends up becoming a commodity. It's something that you could actually make money with. So there are really interesting solutions that might be able to actually solve across. Now, I know I'm not being specific in potential solutions. I think that's a great answer. Again, when it comes to areas with energy scarcity, that's part of what I was also trying to address when it comes to groundwater, for instance. The energy scarcity seems to largely be coming from us already pushing the system beyond what its limits are. And the farther you push the system, the more energy it requires to extract water deeper and deeper down. And at a certain point, you end up having brine water filtering into the system because of either deep ground brine or brine coming in from the sea because of depleted underground aquifers. And in those situations, it only increases the amount of energy that's required. So the solution becomes, in this case, less how to make a groundwater extraction more energy intense, more energy effective. But I guess the solution seems to look more like how do we restore groundwater so that would also address the energy challenges.
And just to add to that, there might also be then an opportunity to deploy, or maybe there's a case to be made that both can be deployed better together so that you have more deployment of renewable energies, electricity, and just renewable heat as well, and like water purification or water generation. So there might be might be like synergies between deploying both together.
Yeah, really, really great point. I can't see if there's any more questions. I closed out the question. Here it is. Yep.
At the moment, there's none.
Yep. All right. Thanks. But yeah, thanks. Yeah, that's certainly one of the points. And oftentimes that's exactly where we try to find some of our solutions is where can we, is there an interface that can have a single solution that could end up benefiting both sides? To briefly add on to also that last area of interest, particularly addressing the rural areas, there are some potential new solutions, especially when it comes to smart water infrastructure. I understand that's a bit of a catchphrase, but where a lot of solutions to also address cost can also be addressed by looking into the actual local water extraction. I think there's a couple of solutions in sub-Saharan Africa, and I think some sort of water spigot. I can't come up with a name right now, but yeah, there's some really, really interesting projects around this, including monitoring building usage, monitoring municipal system usage, even monitoring remote area usage, rural area usage with tap meters. So that you can also identify if you end up having overuse of water and also pay for the amount of water use that's extracted, which can also be a cost-effective solution. All right, and EcoEmit Solution asks, in context, what do you mean by making the solution affordable while the focus is on urban regions? How do rural areas come into the picture? So that's a great point. When I was taking a look at this area, and one of the reasons why I explicitly focused on inland urban areas, honestly, was because of the challenge of addressing rural areas. One of the reasons why we pick a particular area in DSV is because we need to see, can we make an impact, right? Do we have enough quote unquote upside? Are there people working in this space? If there's a lot of people in this space, we say there's low neglect because it's not a neglected field. And then 3, is there something we can do? Is there something that we can build a technology on and defend, for instance? Now, in the rural area, potentially there is a lot of upside. Potentially there's a lot of impact you can have. And potentially there's not many people working in the space, so it is a problem. But one of the challenges, which I agree should be addressed, is that there's really not that many, I can identify so many solutions in this space. Aside from, of course, there are some prospective solutions, but one of the areas that seems as if can have a big impact, and also provided that urbanization is still increasing by 2050, we expect to have like 2/3 minimum of the Earth's population, especially in developing countries, increasing to urban centers, which become, you know, a variety of challenges that we need to address in that way. But it also means that the solution in the inland urban areas ends up building out better, having a bigger impact because urban centers are also increasing. But yes, I completely understand where that is. And potentially some of the solutions around, say, groundwater replenishment can help solve, potentially around the solutions of rural water monitoring can help solve. But it's, and potentially some solutions around building modularity into some of these systems can solve. But this is also why we'd really love to, if you have solutions that you think can help solve rural areas, please sign up, founder and residents. We'd really love to hear your ideas. And especially if you have good creative ways, because this is what we're for. We want to build great solutions that can have the biggest impact. All right. Juliet asks or says that they work in the wastewater industry, and there are many cities for using resource recovery technologies to solve both the water and energy issues. Yeah, exactly. Yeah, there's a lot of. I kind of feel like wastewater is becoming more and more sexy for whatever reason these days, and I wonder if it's because, you know, as you put it, people are realizing the tremendous resource that we have in water, right? Now I'm a chemist, and I started out my research and my background in chemistry, and of course one of the things that we all know in chemistry is that water is a solution. Things dissolve into water, and water it carries elements and compounds from one place to another. And I think that's one of the really fascinating potential upsides that I didn't talk about too much in this presentation, is and also something that Aquature, one of our potential projects that we're spinning out, is doing. Can we extract value out of water by turning water back into the water that we need to drink, back into the water that we need for agriculture, back into the water that we need for industry? And I think the answer oftentimes is yes, especially when it comes to, and at the same time, you could even extract value by limiting the value, limiting the degradation of our environment, right? We have runoff issues, we have nitrogen issues, we have phosphate issues, we have all sorts of other issues, pesticides, etc., chemicals that go downstream. But if we can reclaim the compounds that we want to have, and if we can use the energy, for instance, by converting the compounds that we have in water into value-added products, or by converting it into energy, then we're able to, and potentially even store the carbon dioxide at the same time, which is, again, what some of our projects are prospectively doing. Then you provide a really, really nice value-added treatment process, a really, really nice value-added water process that allows you to potentially address both the water treatment issue and also the supply issue at the same time, which I suppose is also heads in the direction that some people were mentioning in the questions today. How are we doing on time?
Good. I think if there are no more questions, I think we can probably wrap up.
Well, let me go ahead and share the QR code one last time. If this is something that you're interested in, I'd really love to hear from you. We are having interviews right now. So sign up ASAP. We'll stop the interviewing process once we find the candidate that we love. We need to have someone that's creative. We need to have someone that's knowledgeable and someone that's not scared to identify great solutions to seemingly impossible questions. If this sounds like you and if this sounds like something that you really care about, please sign up. We'd love to hear from you, and I'd love to see you in the interview. So thank you so much for joining in the webinar, and thank you so much, Pina and Noah, for joining me here today.